HareDB Introduction. What is HareDB? HareDB is a NoSQL database, which is based on HBase. It provides SQL to query data from HBase directly by HBase coprocessor. And also we get better performance through HBase coprocessor. We knew that HBase doesn't provide an UI to manipulate data and tables in HBase. We only have two ways to manipulate the tables and data in HBase. One is from the CLI, and the other is writing some program. Of course, there are some UIs for HBase. However, they usually do not specifically focus on HBase. But HareDB does. HareDB provides DBMS-like web UI, and it also provides JDBC or DBC driver for any programmer who is not familiar with HBase. Why HareDB? The first reason is easy. It is not even necessary to install it. If we want to interact with HBase, all we have to do is clicking the startup script file. Second, it is comfortable. HareDB provides SQL language and data type management with friendly UI. All functions in HareDB will make users more comfortable with HBase, even if the user is a newbie in HBase. The third reason is faster. It provides quick access to the data in HBase. Using HareDB to interact with HBase is faster than using Hive and even Impala. The last reason is compatible. Because all the codes of HareDB are based on the native API of Hadoop, HBase, and Hive, so it is highly compatible in the Hadoop ecosystem. Target users. Our target users are programmers, data scientists, and anyone who is interested in HBase but not familiar with it. Features of HareDB. Some of the features have been mentioned earlier, such as SQL language supported and friendly UI. Now I just want to mention that users not only can put the data to HBase, but also can use the buckle feature. They can be done with the UI. Furthermore, we also have some modules in metadata management. Before we dive into more deeper in HareDB, let's take a look at the software stack first. According to the diagram, we can see that HareDB core is the heart of HareDB. It integrates the Hive, HBase, Hadoop, Kerberos, and Sentry. The boxes with the gray color means that we are still working on that. We will have updated release in the future. Implementation. The HareDB core. Although we keep talking about the HBase and HBase that, actually Hive is the most important part in the HareDB core. Let's go through the Hive core first. When SQL comes into the Hive driver, the first stage of the process is the parser. In this stage, SQL will become a tree object, which is AST, and the AST is as the input of the next stage, which is the semantic analyst. Hive will do some syntax check here in this stage and see if everything is fine. The AST will be transformed into a query block object, which is called QB. And then after the execution of the logic plan generator and the optimizer, QB will become an OP tree. and it becomes a text tree which is running MapReduce in the cluster. Then here comes the here flow. The here flow is very similar to the Hive flow. We take it from the AST node, which is the result of the Hive parser. The AST from the Hive parser is as the input of the here parser. We call it advanced parser. What does the advanced parser do? First, we'll get metadata from Hive here. Of course, if the table from the SQL script, has been created in Hive, we will find information of the HBase table which is mapped to the Hive table. If not, we will assume that the table is HBase table. Second, we check that if the SQL is join SQL or not, because join SQL is a special case for HareDB. Third, we will create a new QB, which is the same class of the Hive QB, and with some extra information we needed. After that, the coming stage is here semantic analyzer. There are lots of words here. First, if the SQL is a join SQL, we will create an external table for Hive and build a QB, and pass it back to the Hive semantic analyzer. We will do some syntax validation here. This is different from the validation of Hive. We check some items such as does the table or column family exist, or something like that. And getting HareDB metadata. We'll talk about the metadata later. And we will create a raw text planner. Our text is totally different from Hive, since we're using HBase coprocessor, while the Hive is using MapReduce. According to the text planner, we will do some optimizations. For example, raw key and index have to be processed first. Some aggregation functions can be done earlier, but some can't. And index field checking. We have special version with index. We check it here. And the last thing in this stage is to create text plan, which is already optimized. After that, HareDB coprocessor stage is the next stage. According to the text plan, we will create an execution plan and pass the plan to the HDFS. This stage is also the coprocessor client, which means that we call the coprocessor from here. Execution. The HareDB coprocessor will be executed at this stage, and the result we call it map result. Because the coprocessor is basically much like the mapper in MapReduce, so in some cases we have to reduce the result of map result. The final stage is named as final reducer. We pick a node randomly in the cluster to do this reduce job, and as the final result into HDFS. Then we pass the path of the result to the client. So far, I've already explained why HareDB can support SQL language on HBase directly. Metadata. When to get metadata? As I mentioned earlier, HareDB will check if the table name in the SQL script exists in Hive meta. If it does, we will find information of HBase table, which is mapping to the Hive table. If it does not, we will assume that the table is HBase table. And we do this in the advanced parser. As we know, HBase doesn't have any data type. Everything in the cell is byte array. If the data is encoded by integer or any other type, The query result from the CLI will show some kind of code that you cannot recognize. So we create here meta that can allow users to define data types by HareDB HBase client UI. And HareDB will decode it correctly. And HareDB will check the here meta in the stage here semantic analyzer. If unfortunately there is no any meta in Hive and HareDB, we assume that everything in the cells is a string. This diagram shows how HareDB gets the Hive meta. As the diagram, HareDB provides three modes to connect to the Hive meta through MetaStore client. The Sentry cannot control the MetaStore of Hive in Cloudera environment. We struggled in this issue for several days. We finally gave up the path we used before and changed it to go with the Hive Server 2. Everything is eventually controlled by the Sentry, and we also accomplished the mission to integrate with Sentry. RESTful service. The last thing we want to talk about is the RESTful service. Talking about the RESTful service, maybe some people will pop up a question. That is, HBase has provided RESTful service already. What's the difference between these two RESTful services? HareDB RESTful service is not only providing the table and row manipulation, but also providing the RESTful service include the Buffalo, SQL, scanning data, and metadata manipulation. So this is the introduction of HareDB. Thanks for being with us. If you have any comments, please contact us at service@islam.com.tw.